So let's look at the T cell development. So the T cell development happens in the thymus. T for thymus. And if we compare B cell and T cell development side by side, we can clearly see that there are similarities. The B cells are going to first recombine the heavy chain and then the light chain, and the T cells are going to first combine their beta chain and then the alpha chain. And they use a very similar, basically identical process. And then the further education is a little bit more complicated for the T cells. So the T cells have a more, I would say, brutal education than the B cells. So how do we get this huge diversity in the T cell receptor? Well, we're going to do a very similar process. First, we're also going to do recombination to generate the beta chain. And again, we're going to use DNA segments from three different categories. And that's the same as what we did for the heavy chain. So if you have problems remembering if beta or alpha goes with VDJ versus VJ, I would remember beta. That reminds me D for diversity. This is the one, the beta chain, that has also the D segments in. So we have here this VDJ rearrangement. So again, our main course consisting out of a choice of vegetables, meat, and carbs. And then the constant region is always the same. It's one plate, it's a beta plate. And then we're going to recombine the alpha chain, and similar to the light chain, here we have also to choose our dessert out of some chocolatey dish and some fruity dish, so just V and J. And then the constant region is always alpha. And now we're going to get into more education of the T cells. Remember, the B cells and T cells are our specialists, so they need to go through this education, this special education, to become naive T and B cells. And the T cell, in contrast to the B cell, has kind of an additional job to fulfill, because you cannot throw things on the T cell. It always needs to be presented via this MHC molecule. We need to make sure that this maturing T cell really recognizes peptide MHC. And so the first really big test it has to pass is what we can call the just right binding test. And at that point, we're talking about an immature double positive thymocyte. So that means, it's obviously we are not yet there. We don't have a T cell, so we call it thymocytes because it's develops in the thymus. And this thymocyte expresses CD3, and this is this signaling molecule that every T cell has, and then CD4 and CD8. So we have not yet made the decision what the T cell is going to become, if it's going to become a CD4 or a CD8. So in the beginning, as an immature thymocyte, they express both CD4 and CD8. And then they do this brutal test that I'm going to talk now about, the just right binding test. So what does it mean? Well, it's a test just to see, can you be a T cell? Can you see peptide MHC? Can you bind moderately to loose to self-peptide MHC on thymic epithelial cells? Because that's the cells that are going to express peptide MHC. And if you can't do that, well, then the cell is going to die, because there's no use of this cell. If it's going to want to be a T cell and cannot recognize peptide MHC, well, then this test is not passed. So it's kind of a pretty basic test. You can think about going kind of to school and saying, did you bring your reading materials and a pencil? Because if you don't even bring that, then you should probably not be in school. So that's kind of the same principle. Now, we call that, if you are able to recognize moderately to loose peptide MHC, that's called positive selection. That's just right binding to peptide MHC1 or peptide MHC2. And that's also part of positive selection, because that's going to determine what you're going to be, which T cell you're going to become. So if you manage to bind to peptide MHC1, you're going to become an immature CD8 thymocyte. If you bind to peptide MHC2, you're going to become an immature CD4 thymocyte. positive selection has two purposes. Number one, you want to make sure that the T cell recognizes peptide MHC at all, loosely to moderate, but you also make this decision, you make a choice if you want to become a CD4 or a CD8 T cell. And the next test is the negative selection, and that's also part of the just right binding test. And just for those of you who know Goldilocks, this fairy tale where the principle is to be just right binding, not too tight, not too loose, just right. And that's this principle. Negative selection is also part of it, because autoreactivity is always a problem when we randomly arrange DNA segments. So we're always gonna create T cell receptors, also B cell receptors, that will recognize self-peptide. And so we want to make sure that if there's too tight binding to peptide MHC on thymic epithelial cell, so the cell should die off. It binds too well. So if you make our test analogy, we can say, well, I'm having to pass this test, but I should also not be too good. So I should obviously get the principles, but I should not receive honors. So now at that point, we're going to have an immature single positive thymocyte, because now the decision is made. So every T cell is going to have CD3, and then we're going to have either CD4 or CD8. And now, it's not easy to become a naive T cell, so you're constantly tested. So we're still in the thymus. The T cell is moving from the outside to the inside, from the cortex to the medulla. And on its way, there are always more peptide MHC complexes to bind to. And we're going to test the single positive thymocyte constantly. We want to constantly make sure, is there still nothing that you're going to react to? If not, you're good. But you survive and become a naive T cell. But if you recognize on your way some stuff and bind too tight, you're going to still die. So it's not a one-time thing. You're always going to be exposed. And on the next slide, I'm going to show you this also based on the location in a picture to see this more clear. So if you pass this test, so you got the positive selection and you underwent negative selection, but you didn't bind too tightly to something, so you're probably not going to be autoreactive. You're becoming a naive or mature CD4 or CD8 T cell. And this is a time when you're going to leave the thymus and recirculate during secondary lymphoid organs with the hope that somebody's going to come and activate you. And you probably know who that is. We're going to wait for the dendritic cell. So what I want to do next is I want to talk about a couple of parts for positive and negative selection, which I didn't have yet the chance to in this overview figure. And one thing that I wanted to point out is a location. Where do these things happen? So we know this happens in the thymus, the positive and negative selection, and the thymic tissue is divided into these lobules. And I just want to point out then that this early T cells, this pro-T and pre-T cells, they hang out in the subcapsular region and then move into the cortex. And that's where they're going to be the first time exposed to peptide MHC via this cortical epithelial cells. So obviously we are in the cortex, so there we have cortical epithelial cells, and they express MHC1 and MHC2, and those always have peptides on their surface. So MHC molecules can never be empty, so they're gonna react with them. And that's where positive selection happens, where this test is, do you recognize peptide MHC? And then we said also, we want to make sure that they don't bind too tight to prevent that we get autoreactive T cells. And this testing continues all the time. Now there's one important consideration. If you think about it, well, if you are tested in the thymus, if you recognize self-peptide, well, which type of self-peptide will be expressed there? Well, thymic peptides. But that's not the full story. You're going to go out in the world. You're going to go out into all different places, and you're going to be exposed to muscle peptides, heart peptides. So how can you be trained with this limited amount of peptides in the thymus? Well, Mother Nature solved this very elegantly by giving us this medullary epithelial cells. So in the medulla, once you reach the medulla, you're also going to be exposed to peptide MHC, expressed, for example, by medullary epithelial cells, or we have also dendritic cells and macrophages there. But they have the potential to show all kinds of different, also non-thymic peptides, because they have a specific transcription factor, and I have this on the next slide also, it's called AIR, and this gives them the potential to present all kinds of different peptides. So it's like those cells in the medulla have a special license to make all sorts of special proteins that are usually made by other organs. So like peptide, they can present peptides from the heart, pancreas, liver, and so on and so forth. Okay, so let's just sum up the T cell development. And again, we start with this pro-progenitor T cell. Again, it's not professional. It's kind of the one that has the least idea. It doesn't even have a T cell receptor. Without receptors, start first expressing the rearranged beta chain. So that's the one that comes with the VDJ rearrangement. And if we zoom in, we can see that's a beta chain. And then there's just a placeholder, such a surrogate alpha chain. So that's not a real one. It's just that it holds the beta chain up. And then we're going to move towards also rearranging the alpha chain. And at that point, we're talking about an immature T cell. And this immature cell is double positive when it starts the education. But then all these hard tests come, the positive and the negative selection is just right, binding test comes. And then in the end of this immature T cell, we're going to talk about a single positive T cell, immature single positive T cell. And then eventually this cell, if it doesn't bind too tight, it's going to become a naive or a mature T cell and expresses a T cell receptor. It's also single positive. And I just put in here an asterisk just to remind you about positive and negative selection, and just also to have on one slide all the different scenarios that you can see. So we said, well, the most important thing is, do you recognize peptide MHC? And either peptide MHC2 or peptide MHC1. And that's positive selection. So at that point, you're positively selected. You said, okay, so you're going to be probably a good T cell. So we want you. If you don't even recognize that, you have basically no idea. And that's called then a lack of positive selection. And at that point, the cell is going to die by neglect. It's basically going to starve to death. And then the other point, which is important on your whole way through this very challenging education university, you want to avoid to have strong recognition of either peptide MHC1 or peptide MHC2, because if you bind too tightly, you would also die by apoptosis, and that's called negative selection. So these are the different things that can happen to the T cell by going from this step, kind of from the beginning of the step of an immature T cell to the end of the immature T cell, and then on the way of becoming a naive T cell. This concludes the video on T cell development.